Hello, everyone, and welcome to our webinar, Scalable CEP in Private and Public Clouds. Today, IntegraSoft CTO Michael DiStefano and Nati Shalom, GigaSpaces CTO, will talk about complex event processing services within the cloud. Please feel free to send us your questions during the webinar using the chat tool. We will respond to your questions during the Q&A session. Also, during the webinar, you will be prompted with 2 polling questions. So once these questions come up, simply choose your response so we can learn from each other about our opinions and preferences. I wish you an enjoyable and interesting webinar and urge you to fill out our survey at the end of the webinar as your input is viable to us. I will now pass the mic to Nati.
Thank you, Maya. Thank you, everyone. Thank you for joining our webinar. The CEP with GigaSpaces and Netsphere. I'm very happy to have a partner of ours, Michael DiStefano, and a good friend from years. And Michael is actually going to do most of the talk today. I'm going to start by introducing GigaSpaces, and then we'll go through what is CEP and what is IntegraSoft, who is IntegraSoft, and basically talk about the integration and how it works. So the bulk of the talk is going to be by Michael, and I'll start by, for those who are not familiar with GigaSpaces, with a quick intro to GigaSpaces. So GigaSpaces has been around for 10 years. Michael, if you can switch the slide here. We've been in the space of distributed computing for a while. Basically, what we do is we provide a solution for enabling applications to scale the data or their application using an in-memory middleware. And that's been our primary, I'll say, market up to now. And basically, the integration that we'll talk about, we'll see how we can apply all the core scalability patterns that we've developed and the capabilities that we have in our middleware within the CEP area. Our list of customers coming mostly from the financial industry, but also with other markets, the e-commerce one, online gaming, and other markets that have growing demand for scalability. With that, I'll finish my part of the talk, and I'll switch to Michael. Michael, the floor is yours.
Thank you, Nati, and thank you, everyone, for joining us here today with this webinar. I am Michael DiStefano, partner and CTO at IntegraSoft. We're at IntegraSoft. We apply distributed computing technologies and techniques and paradigms, grid, cloud, CEP, to financial services. Today, we'd like to talk to you about applying CEP to the more common business and IT challenges faced within financial services and how we can overcome some of the limitations with CEP to address these issues. High-frequency trading, program trading, market fragmentations, these are realities in financial service today. And all of these together have increased data rates at a very quick and rapid pace. And as the data rates increase, as the order flow and the quoted market increases, the response time that the trading systems have to make their decisions and get their next trade out the door continually shortens. And it's these trading systems that not only are keeping pace with these market data rates, they're setting the pace, right? They're putting together all these strategies and executing them. What has not kept pace are the other systems within the trade life cycle, the middle and back office, the position keeping, risk surveillance. And this has led to a discontinuity in data processing rates between the trading systems and these other systems in the trade life cycle. And this discontinuity has become very apparent last month in May. We had a 1,000-point drop in the market that has unfortunately grabbed the attention of the government and the government's regulators, which means that at some point fairly soon there will be new regulations coming down, whether that's in the form of a cross-market audit trail, a holistic audit trail. We're not sure. But what we are sure is that these other systems, right, the middle and back office, needs to be brought up to par with the trading systems when it comes to data processing rates. And as CEP has been a tool, or one of the tools used in these trading systems, it can be a tool used to bring the post-trade and the position risk surveillance up to par with the data processing rates. But we do need to address some of the challenges when it comes to using CEP in these other systems, as these systems are truly enterprise systems. They touch every aspect of the enterprise. So we need to address, from a developer standpoint, a lack of standards. From an enterprise standpoint, integration, ease of integration into the rest of the enterprise, as well as be able to leverage one of the key components that corporations are starting to embrace, which is grid and cloud computing. So how can we take CEP, which is today primarily a server or a cluster-based deployment, and have it take advantage of the flexibility and the fungibility that a cloud offers today, the ability to expand and contract based on business demand? This is what we are addressing at IntegraSoft, the data integration issue, as well as what does it mean to have a CEP-based service that runs within a cloud? Okay, so what is a CEP service cloud? So for this discussion here, let's just view the cloud as this two-dimensional array where each point within the array is a single instance of a CEP engine on a network. The footprint of a service within this cloud can be expand and contract and run on as many CEP engines as it needs to meet the business demand at that time. And these services can be co-located. So single CEP instances can host one or multiple services, so that to efficiently address data and event sharing between the services. Now, moving from this theory into practice, distributed CEP is the underlying backbone of something that we at IntegraSoft use to actively manage large distributed infrastructures. We have these distributed services, or what we call adapters, into every layer within the service stack, the physical, virtualization, as well as the business layer, so that we can monitor and make smart decisions and take proactive actions in resolving issues as they occur within each layer and then holistically across the entire service stack. And this is made possible by the fact that we have these services that can expand with the grid. So as whether you have 10 nodes, 20,000 nodes, we can expand the services without infacting the business SLA with the active management software, which is to ensure certain response times with the cloud infrastructure. So how do we start defining a CEP service? There are four main components. We have, each service has its own processing loop, right? Just as with any other program, there's typically a main processing loop. And in this loop, you have the flexibility to insert your own code if need be. Business events become the interface of the service, whether it be the private events to help implement the service, or more importantly, the public interface of the service, how other systems, whether they be other distributed CEP services or other external systems with the enterprise, will interact with the service. The implementation of the service is a combination or a seamless integration between the business rules CEP rules themselves, and business actions, which are procedural code snippets. And this is a seamless integration of these two rules and actions. To start forming the infrastructure of the CEP Service Cloud, we have what we call the service daemon. The service daemon does a few things. It encapsulates the CEP engine. In this case, it's ESPA. It also can manage or host the execution of one or many services within that process. So each of these services share the same CEP engine as a common resource. Data integration is achieved through borrowing terms from straight-through processing, input and output adapters. Input adapters can be tightly bound to the external system through the event processing loop, or can be loosely coupled through an enterprise service bus. Similarly, output events can be tightly bound through the actions or loosely coupled through the enterprise service bus. And it's the enterprise service bus that is the communication backbone between all the daemons that allow your CEP services to interact with each other throughout the cloud. Through the service definition and this infrastructure, we achieve data affinity. When data affinity is always important in distributed computing, it allows us to move the CEP instances of the service out to where the data resides within the cloud. This eliminates unnecessary data movement across your network. It allows us to scale as the business demand requires, to partition our services so that we can scale, taking advantage of all the benefits that a cloud infrastructure provides.
Michael, we'll switch to the following question right after this slide when we'll get to the GigaSpaces and Integra stuff. So finish up with this slide and then we'll switch.
Very good. So we're going to talk about
the first following question.
We've already switched to the following question, so everyone can answer the following question. Maya, did you want to say anything?
The first following question is, are you using or planning to use any CEP engine solution? Please select one of these options. I am using CEP engine today. I am planning to within the next 3 months, within the next 6 months, 12 months, or not planning to within the next 12 months. Okay, 50% have voted. I'm waiting for the rest of you to vote. And I'm closing the poll in 5 seconds. And the poll is closed. So I can see that 75% of you are planning to use the CEP within the next 12 months. Okay, Michael, if you would please continue.
Thank you very much. We're going to show an example that touches upon the various components in the trade life cycle. We have in this example, and we'll actually show this running, consolidated orders, a consolidated order feed that'll have executions across all the markets. We'll have exchange feeds that will consume the orders, take the orders in, and it'll do a few things. It'll validate the order to make sure the order is within the quoted market. And if it is within the quoted market, we'll auto-generate a new quote to reflect the change in the marketplace. And if that order is outside the quoted market, will generate an exception. This way, we don't start quoting off of erroneous orders. And for the trader, we have a market analysis service that provides for the trader indications as to how the market is leaning, what is the market sentiment, and that he will use this, the trader will use this to as a barometer to see is the market leaning closer to the bid or closer to the ask. And once he's decided what his next trade should be, we'll give him an indication as to what is the top of market, which exchange at that instant in time is providing the best quote to execute that order.
Okay, so now I would like, with your permission, Michael, to ask a second polling question. I'm now launching the second poll. And the question is, if you're using or planning to use a CEP engine, for what purpose would that be? Would that be for trading systems, trade executions, or position risk surveillance? Okay, I see that 20% have voted. We are waiting for the rest of you. And I will close the poll in 5 seconds. We have 60% voted. And the poll is closed. I can see that 50% think that they will use it for trade execution, and 50% are interested in position risk surveillance. Michael, if you would please continue.
Yeah, very good. So in this demo, we're leveraging integrations into GigaSpaces at a number of different levels. First, we're using the JMS, or the ESB aspect of GigaSpaces that'll interconnect the various CEP service instances within the cloud. We're using another space, a stock demo space, that is business specific, that other applications in the enterprise, in this case a graphical interface, will connect to display the current market to traders. So we have the order feed service generating its consolidated order stream out in 2 different directions, out into the JMS space for consumption by the other services within the cloud, as well as and those consolidated orders being shared by those services are events. Okay, and out into the stock demo space, where we have a tight coupling into the space so that you can put your own objects directly into the space from a CEP service as well. So here we're showing loose coupling across services through the JMS space, and a tight coupling by putting the objects into the stock demo space. Now the quote service feed is partitioned so that we can have as many instances of the quote feed service as we need. And we'll talk about how services can be partitioned in the next slide. Just that this quote feed is partitioned. There are multiple instances of the service running within the cloud so that we can handle the load. Now, what happens here is the orders are subscribed to the quote feeds, and the new quotes are published back out for downstream processing through the market analysis service. What's pushed out into the stock demo space are events, which are the exceptions. Remember, we're doing data validation. Is the order we just received in within the quoted market? If it's not, it's an exception condition. You don't want to process or auto-generate a new quote. And the market analysis service takes in the new quote, and it provides this business view that traders will use to determine what their next trade should be and where that next trade should go for best execution. Now, remember we talked about partitioning the quote service. Services can be partitioned across work or across data, right? And this is a design paradigm. So as you're designing your service to be scaled out within the cloud, we can decide which is the best way to partition a service so that we can scale it out within the cloud. And this is one way to naturally scale services out within the cloud. I want to take a moment and start looking at exactly how these services are implemented. The quotes feed service is only 6 lines of code. Now, event processing within financial services is not new. We've been doing it for a long time, and typically it's done through procedural coding. If we were to implement this quote feed service in traditional methods, it would be more than 6 lines of code. In fact, it really boils down to 2 lines of code. The others are in support to get to these 2 lines here. We have 1 line of code that validates and requotes the market, and the other line that does the data validation. It says it's outside the quoted market. Please generate an exception. The code within events sort of looks a lot like SQL, and in fact, since we have a binding into Esper, the SQL syntax is itself EQL. This also shows the seamless integration between rules and actions procedural code. Here, what we're doing with auto-generating a new quote, when the rule, we're publishing that event out to, as an action, out to the rest of the services that would be subscribing to quoted markets. In the exception statements, we're publishing out to a space. So we have seamless integration between rules and procedural code. Your developer does not need to have to worry about how all this happens. He just has to worry about the business logic as to what it is that I'm looking for and what do I need to do with that data. And similarly, on the market analysis service, again, happens to be another 6 lines of code, where one of the lines shown here determines the market sentiment, and the other line determines which is the top of market. There's one key difference here is that the actions isn't just one action. You have the ability to invoke multiple actions as a result of events and rules triggering as true. In this case, market sentiment is being published out to a space as well as being printed to standard output. And similarly to the top of market, we're publishing that out to its space as well as printing it to standard output. These 2 examples show the 2 main reasons why CEP is grabbing a foothold. It allows the developer to do fairly complicated things with event processing and event correlation very simply. We can join any number of data streams together as if they were tables within a database. And the resulting logic, the number of lines of code, the amount of work a developer has to do to deliver that piece of business logic are relatively few in comparison to the alternatives of using procedural paradigms. So it allows you to do quicker things, difficult things fairly simply, and it allows you to get to market quicker by shortening development lead time. What I'd like to do right now is show you this demo. And to do that, I have to exit out of the application here and show you the setup. So here we have, within GigaSpaces, we have our 3 spaces. We have the JMS space, we have the stock space, and we have our front end here. What I'm going to do is show you the example. And right now, I am going to start the order feed service. Here in this green window with the light characters, we have the market analysis service. And in the 3 windows, the black windows with the bright green lettering, those each are the exchanged services. So as we're seeing, if you recall, one of the actions in the market analysis service is we're printing things to standard out. So here we're seeing some events starting to happen, top of market events are occurring, and we're printing them to standard out. But we can also see these events going into the spaces and being processed by the various components within the enterprise. And I just want to see if I can get one more stock in there. And one other thing I would like to show you is once we move into the spaces themselves, we can show you what's being put into the spaces. Here we have CEP events directly, and we can query these events and show you that indeed there are exceptions going into the space, as well as top of market, as well as market sentiment. At this point, I'd like to open the floor up to discussion.
Okay, thank you, Michael, very much. We now have some time for some Q&A. So the first question I would like to ask is this solution targeted only to the financial services, or can I use it for other purposes?
I'll give my part of that, and Michael, you can add on. And by the way, everyone on the call, please use the chat to fill in your own questions. Feel free to do that. So essentially, the real-time analysis and CEP is a solution for real-time analysis, and obviously the demand for real-time analysis expand across different verticals and different industries. Actually, I was in the Hadoop Summit yesterday, where the demand for real-time analysis came out, I think, across the board. From different people on the audience, where one of the reasons that they wanted to be able, like in Twitter, to see the trends in the market and be able to react to that in a timely fashion. In some cases, you want to be able to show frauds in credit card kind of processing. And obviously, if you have a latency or it takes time to actually detect that fraud, then you're losing money. And that was the case that was brought with Visa. So there's a lot of demand for it, I think, that is growing from that social networking companies and social networking side. And it becomes much more visible to the business that the more they know what the users are doing with their site, with their service, with their application, the better they can be able to compete. So it's not just the regular risk analysis that we've seen in the past, which was kind of a niche market. It's actually broad, and almost every organization, every application will need to have that as part of its system. And Michael, maybe you want to add to that as well.
Sure. This is a cross-vertical solution. Just the going to how the distributed CEP cloud came into existence in the first place, and that has not with a financial application, but with how do you manage these large distributed environments where you have large volumes of data being published from one or many thousands of sources. And the ability to keep response time within business SLA, right? And this is the interesting part with cloud computing. The infrastructure and the applications are judged by the business. Are my SLAs being met, my service level agreements? If I'm expecting a price calculation to return within 200 milliseconds, the infrastructure better be able to do that. And if it fails to do that, then the SLAs aren't met, and the business users who have a contract with the infrastructure won't be happy. right? But we see within financial services that as the business applications themselves that need to deal with position keeping and surveillance and all these other problem statements that are common within financial services, this distributed infrastructure applies.
Thanks, Michael. Maya, what's the next question?
The next question is, how is the event processing with CEP different from the event processing I get with GigaSpaces?
Yeah, so basically, if I want to answer to that, event processing been around for in GigaSpaces, and the whole JavaSpaces model was actually built for that. The thing is that it required a lot of code to do the type of things that I think Michael showed here. So what CEP really provides is two things. One of them is an abstraction layer on top of that that provides a much simpler way and declarative way to define things that previously to that you have to write a lot of code to actually accomplish that. The second thing is all the aggregation, being able to aggregate a lot of information from different data sources, in our case, different partitions. That's something that in itself is also can be fairly complex, especially if you have all this dependency and timeline dependencies, where you need to kind of do queries on a period of time and not just on the actual event or in a concrete event that you just arrived and you need to filter it out. And CEP provides a mechanism to buffer those events into, if you'd like, an on-demand table that is created per user that enables him to do this type of sophisticated filtering. And those are the type of things that make the CEP as an add-on very useful for existing GigaSpaces users to make their life simpler. And Michael, do you have anything to add to that?
Just to reiterate the advantages that CEP offer, which is why it has gained market adoption in recent years. Through simple statements, and these statements look a lot like SQL, depending on the event engine you use. In this case, Esper and some of the other engines have an SQL-like syntax. It lowers the barrier of entry and allows you to do fairly complicated things with real-time events fairly simply, speeding time to market.
Okay. The third question I get from the audience is, how scalable is the solution?
Michael, do you want to take that?
Sure. Well, the solution scales along two ways. It allows you to take advantage of the cloud and the cloud infrastructure. So the other part of the integration with GigaSpaces we didn't talk about is the ability to spin up more instances of your services as they're needed. And as long as the infrastructure allows you to do this, you have the available CPU and bandwidth within the cloud, you can continue to spin up and scale. However, the limitation in scaling within each service starts to become a design question for that service. Remember, I mentioned earlier, partitioning services along work or along data or along both. Right? Some services can be naturally partitioned, which means you can start spinning up as many instances as you need along those partitions. Right? If some services may not naturally partition themselves to a thing to take advantage of a cloud. In these cases, you can look at perhaps subdividing services, a larger business service up into servlets. But this will become, the combination of from a design paradigm of partitioning services to the ability to provision out. There are no inherent limitations within the underlying infrastructure because we're taking advantage of a lot of the technologies that are commonplace today, right? We're taking advantage of enterprise service buses, and depending on your data flow between the services, you can use very high performance service buses similar to what we use for market data, or if you need transactionality, you can take advantage of service buses that that offer that quality of service level.
Okay, great. Now I have another question, please. And the question is, how is this solution better than other CEP solutions?
Other CEP solutions on the market are typically single instance server or server-based, or perhaps you can create a cluster of CEP engines together. But the engine, the CEP engine is either perhaps embedded into your application directly, or it's a single server where the data or the events have to move from wherever they're being generated to that server or to that cluster. Right? What this allows you to do is to push the processing or the CEP engines themselves, right, the services themselves, out to the data sources so that you're not unnecessarily moving events across a network. You're processing the events, and you're embedding your business logic as close to the data source as possible. So this allows you a few things. It minimizes network traffic, unnecessary movement of these events, and in some cases, these event rates can be very high. And it also allows you to break the server or the hub and spoke paradigm, right, and allows you to start scaling out to take advantage of the elasticity that clouds offer.
All right. Thank you so much, Michael and Nati. At this point, we're going to end our webinar. We would appreciate it if you could please fill out our survey. Please note that in a few days, we will send you a link with a recorded session. I would like to thank all of you and to wish you a great day.